I'm Lin Haoxun, and my student ID is B11901153. And today I'm going to explain the solution to the problem set Unit 2, number 6. The question tells us that we throw a bow at a 45-degree angle to the horizontal, aiming at a friend who's sitting in a tree a distance edge above level ground, and at the instant we throw our bow, our friend drops another bow. And we need to show that the two bows will collide no matter what's our bow's initial speed, provided it's greater than some minimum value. And we also need to find an expression for that minimum speed. So now we first draw a graph for the question, and we set the bow we throw is bow A, and we set the bow our friend throw is bow B. And we know the distance here is h, and we also know the angle here is 45 degrees because the question tells us that we first aim at our friend who's sitting in a tree, and we throw the bow at a 45-degree angle, so this angle should be 45 degrees. And we also set the initial speed we throw the bow is v0. And this question I would like to use relative acceleration and relative velocity to help us solve this question. So we need to find both of them. And because both bow A and bow B has an acceleration g downward, so the relative acceleration equals to 0. And because bow B, the initial status of bow B is static, so the relative velocity VAB equals to V0 minus 0 equals to V0. And next, we find the distance between bow B and bow A. And since we know the distance here is h, and we also know the degree here is 45 degrees, so the distance between bow A and bow B is h over sine 45 degrees, and it's equals to 2 square root times h. And now we set x equals to the time b takes to fall from tree and reach the ground. And we set t equals to the time when A and B collide. And from the formula of uniform acceleration, we know that x equals to 2 times h over g square root. And from the relative velocity and the distance between A and B, we know that t equals to 2 square root times h over v0. And now we derive an inequality. If t smaller or equal to x, then A and B will definitely collide. So it means 2 square roots times h over v0 smaller or equal to 2 times h over g square root. And we can derive another inequality that v0 bigger or equal to g times h square root. So now we find the minimum speed is g times h square root. And if the bow's initial speed bigger or equal than this, bow A and bow B will definitely collide.